the tension is can we come up with something different or better that's more effective for how you do computing and AI and sort of on these high-end systems?
On this episode of Embedded Insiders, Ken and Tom Gall, VP of Technology at RISC-V International, discuss the future of the organization, development plans, automotive, HPC, data centers, sustainability, and more. Next, Rich and Vin are back with another Dev Talk featuring Kevin Liu, the Associate Dean for Engineering and Science for Undergraduate Studies at Stevens Institute of Technology. They discuss how to ensure students aren't cheating by making use of AI and how to ensure that the careers you are getting them ready for are the right careers. Is this changing the world of AI? But first, Ken and I highlight RISC-V International becoming an international organization for standardization.
Well, hello, engineers, friends, and embedded professionals all over the world. Welcome to another episode of Embedded Insiders Podcast. I am Ken Briota, Editor-in-Chief of Embedded Computing Design, and I am here with our Managing Editor, Tiara Oliver. Hi, Tiara.
Hello, Ken.
What an exciting time. I am just recently returned from Las Vegas and CES, where I had a chance to sit down with some of our friends from RISC-V and actually the Edge AI Foundation as well. We sat down and had a lovely little discussion, and part of what came up in that discussion was the fact that I'm jumping right in here because I'm very excited about this news, was the fact that RISC-V International is becoming an international standards org. They're well on the path. They had a big milestone last fall. And I think that's a really cool, interesting development, don't you?
Yes, I'm excited to see where that goes, and I know hopefully that'll tie into our next interview pretty well because it'll be with RISC-V as well.
Oh, yeah, that's right. We talked about a wide variety of stuff around RISC-V in that interview. And this move to become a standards org is really interesting to me because it's not an easy thing to do. You know, there's a lot of hoops you have to jump through, but um, as an IP, like a silicon IP, for RISC-V to make this step is a really cool move to make it easier to adopt across
Mhm.
different industries and things. I think it's a really cool idea. I think sort of the impacts are going to be the folks who are already playing with and working with and implementing RISC-V. You know, there's many, we've talked about it many times, but what this is going to do is help encourage people who've been slow to adopt to get involved. I think it's going to make it easier for them to innovate on top of RISC-V, and that's how you end up really becoming ubiquitous and used across. Because RISC-V is exciting to those of us sort of deep in the sauce, but it hasn't really caught up to some of the other IPs, the x86, the ARMs, and in terms of adoption rates yet. And this is a great step in that direction, I think.
Yeah, and I know last year we covered quite a bit of news about them as far as the adoption in general and then their new CEO. So I feel like this is kind of a cool next step and they're kind of on a path to acceleration, it kind of seems.
Yeah, yeah, absolutely. There was a summit in Europe recently, and of course they had their North America summit last fall. So yeah, there's so much news coming out. I think RISC-V is on an upward trend for sure. So we wish them good luck in the ISO and getting that finished. And I think it's time to hand us off to past me having an interview. But before we do that, tell us a little bit about what past you was up to yesterday.
Yeah, so this week I attended an event with John Deere to view their next generation of excavators. So I won't say too much about it now. I'll just tell everyone to stay tuned and there'll be an update online. So you'll get to see hopefully some cool pictures and videos and some great news.
Marvelous. Make sure you're visiting embeddedcomputing.com for that news and all the news that comes out in embedded. Make sure that you're subscribed to this podcast if you have found us by some other means. And make sure you subscribe on YouTube if that's where you're watching or listening, because we're rolling out, due mostly to your hard work, Tiara. We're rolling out video podcasting this year. So you're going to be able to watch some of these interviews, not just listen to them if that's your preferred flavor of podcast. So make sure that you're liking, subscribing, sharing, send these things. It helps us out and helps get out these important stories. But in the meantime, I suppose we ought to move on to the episode proper, right here.
Yep, sounds good. Stay tuned, everyone.
All right. Bye, friends. See you soon.
Now, here's Ken and Tom Gall, VP of Technology at RISC-V International.
Hello, friends. Welcome to this segment of the Embedded Insiders podcast, our weekly podcast all about everything embedded, exciting, and designing in the entire embedded computing space. I'm Ken Briota, editor-in-chief of Embedded Computing Design, and I'm very excited to be here with Tom Gall of RISC-V International. Welcome, Tom.
Thanks, Ken. Happy to be here.
The pleasure's entirely mine, and as they're about to find out, our listeners or viewers, now that we are a video podcast. Tom, you want to tell the folks a little bit about yourself and your background in case they're not familiar with you?
Sure. So, of course, I stepped into the role of Vice President of Technology here at RISC-V International. But prior to that, I started my career at IBM. So probably most notably, I was a member of IBM's Linux Technology Center for a number of years. I was the chief architect of IBM's embedded Linux program for a while. So we shipped embedded Linux and all sorts of fun things. Actually, there was a time where you couldn't turn on, certain computers without an embedded Linux actually booting first, which was kind of cool. So I did IBM for 20 years, and then after that, I went to a company called Lenaro. And so Lenaro, of course, was all about the ARM ecosystem and getting a number of companies to get together, collaborate, and make that software ecosystem strong, at least when it came to open source software.
So x86, then ARM, now RISC-V.
And PowerPC was also in my past, and I will fully admit I was a very big fan of the Motorola 68,000 series as well.
Every now and again in these tell me about your past and your bio discussions, I flash the old Aslan quote, do not quote the dark magic to me, which I was there when it was written. I was talking to somebody about Prodigy Online a couple of weeks ago about text-based internet and how we were all sort of just writing, describing things instead of having pictures. It was a interesting time.
Oh yes. And downloading floppy images over a 1200 or 2400 baud modem in there, or even 300 in the early days.
Yeah.
What an experience.
Really stretching the capabilities of my Commodore 64 back in the family room. So that's enough about the past. Let's talk about the right now and the future, Tom. You've just come into the role here at RISC-V International. RISC-V has been doing some really exciting things in a lot of different areas. What are you excited about? What are some of your aims and goals going to be?
Well, there's a few things that are just percolating that I think is going to make 2026 pretty exciting. So first and foremost, I think, the thing to probably impress on everybody is RISC-V International. We're more like a standards organization, right? We have, this wonderful ISA that's been designed over the years. And then, over time, we've seen extensions that have been added to it, like vectors and other kinds of, purpose optimized opportunities for companies to go and, pull it into their IP and make a great device for embedded systems or even other, computing solutions. And the fun thing that's going to happen in this next year is RISC-V International has become an ISO submitting standards body. So this means that the RISC-V ISA is going to become an ISO standard here in the not too distant future.
Wow.
So, having this worldwide thing that is an ISO standard is pretty darn cool. And
That's
then of
very
course,
cool.
yeah. And then of course, then the next thing that you have is okay, so your standard. Well, what can you do with the standard? And what's going to happen? And so for us, there's really a few things which in 2026 are pretty exciting. So we've got this profile that we released as a spec called RVA 23. And so of course that happened this year. There's going to be a little tweak to that called RVA 23.1, but it's not a big changer. Besides, there's some necessary things that you want to change and improve, right? You know, as we go into the future, we want things to get better, and that's how you do that. But the fun thing is then when you have a profile like this, which is all about sort of uniting the software ecosystem so that you can have these binaries that work commonly across all of these systems that are RVA 23 compliant, and you have single binaries that boot on multiple different machines, all that kind of great stuff. So you get some great commonality going. Well, you need hardware. And when's the hardware going to start to show up? Well, it looks like it's going to be in 2026, of course.
Yeah.
And well, I can't pull out the crystal ball and tell you exactly this company, and this company are going to be shipping on such a day, because wouldn't that be fun? Oh, no. But as people are going to start to see, there's getting to be more and more announcements of either
Yeah.
dev boards or systems that are showing up that are basically going to be RVA 23 compliant. Even in 2025, we'd see the systems and vendors pop up and just say, hey, we're designing this thing, it's going to be really awesome, and it's going to be RVA 23s. So this 2026, I think, is going to be a lot about RVA 23 and the hardware that goes
Yeah.
with it.
That's huge. I mean, that's really, really cool. The conversion or well, not conversion, but the adding in the capability and doing the standards body piece as an ISO is exciting. That's really, really cool. That process must have been complex in getting that all put together.
It is because you're coming in from something that you've been authoring as a standard spec, but not united with a standards body. So you kind of got to get with the
Yeah.
times and go, okay, well, what was the proper process, and how do you change yourself so that you kind of retrofit and fit in?
Yeah,
Um,
absolutely.
and then
That
there's another thing that for the embedded space that people are going to be interested in, and that is
sure.
we've got another profile coming that we're starting to work on called RVM for
Interesting.
MCUs
Okay.
and things like that. So this, we'll see how long this percolates and takes, the various smart people in the room that form the committee
Yeah.
to pull together this profile. But that is one of the things that's going to get worked on here early in 2026, and it would be awesome if we can get it out this next year
Well,
too.
can you tell me anything about it? What are some of its intended targets? I mean,
Yeah, it's really down for the embedded space. I mean, we're really,
yeah.
you're talking MCUs and things like that.
Oh,
Um,
okay.
So
That's
yeah,
awesome.
the Zephyrs and all the other RTOSs and things like that probably should be able to take advantage of it. But yeah, we'll see where
Yeah.
it goes. Because the thing is remember, you got a bunch of smart people getting in the room, and they're going to impose their vision of what they think sort of, you know, what this M profile should be all about. So,
Yeah.
people can get creative, and that so will result in something
Absolutely.
awesome.
So the big story in the North America RISC-V Summit in 2024 was automotive, and then all through 2025 there was a lot of development in RISC-V for automotive, and not that that's
Yeah,
the only place, but that was a big story. And
yeah.
is that still sort of a big leading front for focus for the organization? Are you um focusing on other verticals, or are there some other big stories that folks should be paying attention to with RISC-V?
Oh, so okay. So in the case of automotive, we've got an automotive SIG that's come together. And so, the idea is, of course, RISC-V International, we're a membership-driven organization. So,
Yep.
we've had a number of companies come together that are, of course, all engaged in the automotive space. And so, one of the things what they do when they initially get together is they say, where's the gaps? What's missing? What's not quite right? What could we do here? And so they
Hmm.
they they start looking at things with fresh minds. The other thing that they do is they also look at all the other kind of complementary committees that are within RISC-V that sort of are utilized within the automotive space. So, for instance, we've got oh, so we've got a safety. Uh, I'm fumbling over the word. so, so we've got a functional safety SIG.
Hmm.
I was missing the F.
Yep.
And we've got trusted computing, we've got a server SOC committee, we've got a hypervisor committee, and runtime integrity. So these are all kinds of things that are as deeply important to automotive. So they don't necessarily have to take on those tasks within the particular committee. You can kind of string all of this together, sort of whisper in people's ears and say, hey, we need this for automotive too, and make sure that as they're working in their own respective spaces, that then it also takes into account what automotive is.
Yeah,
So
I mean, it's not like these technologies aren't cross-platform and cross-vertical in some ways. And a hypervisor is a hypervisor, so long as it meets the requirements, for, broadly speaking, right? I mean, that's fair to
yeah,
say.
yeah, it is. I mean, and the thing is that what might be a great hypervisor for, say, like a hyperscaler, or sort of the kind of cloud computing environment, and what you want to do for a car, they can be a little different, but that's okay. I mean, there's definitely
Sure.
areas of technology that are overlapping. You're quite right that what is good for one can oftentimes be really, really good for the other.
Yeah.
Um,
A lot of the broad speaking news has been AI, especially at the edge. Risk
yes.
Five's always been sort of very good at edge management and stuff. So I assume there's still a lot of focus happening on that front.
There is. And so I think there's kind of a couple of really interesting conversations to have here in this space. So one of which is, you see RISC-V cores already in GPUs today. In addition to that, there are RISC-V cores which are being sort of crafted into sort of custom designs that then companies are shipping as accelerators. So
Yep.
black hole, for instance, is one of them. So look it up. It's a fun one. Just do RISC-V black hole. Google is your friend, as they say. And um, and then the other kind of fun one that I'll note too is that there was one that was done by Meta, and so it's called MTIA. So there's a couple of they did a blog post, they did a paper back in, I think it was 2025, 2024. It was one of the twos where they kind of talk about this architecture of
Hmm.
how do you take a bunch of cores, enable AI algorithms where you maybe want to load the data but not move the data, and allow the cores to be sort of different parts of the algorithm.
Hmm.
And so again, as a way to kind of accelerate things. So there's a lot of innovation kind of going in this space. I was recently at supercomputing down in St. Louis a few weeks ago, and there was a really interesting sort of tension in the background. So these are all folks that work in high-end systems. If you think about it, these data centers that are getting built across the United States right now, or across the world, they're really all high-end supercomputers in one respect or another.
Yeah.
And so across these high performance computing spaces, the thing that people are, sort of realizing is that you sort of have this one-to-one relationship where if you want more computing power, you add another GPU, you add another machine. And so it's a one-to-one relationship, which also means that you increase the amount of electricity that you're consuming.
Yeah. Yeah.
And so where they've sort of kind of come to this realization is, hey, wait a minute, we're going to hit bounds because we can only build these things so much, otherwise you're just consuming crazy amounts of electricity and stuff like that. So the tension is can we come up with something different or better that's more effective for how you do computing and AI and sort of on these high-end systems? And
Yeah.
so, is that GPUs? Is that not GPUs where you string a bunch of purpose optimized cores together, like what Meta has done with RISC-V? Good
Hmm.
question. Nobody knows yet, but that is state of the art. And that's part of the fun here. And it's great to see
Yeah.
that RISC-V is kind of involved on both sides of the fence.
Well, I wanted to dig into that a little bit because obviously, as you mentioned, one of the big issues facing computing in general and the AI space specifically is energy use.
Yes.
As the servers get bigger and more powerful, they're using a ton more energy. I think I saw recently that if not now, soon a quarter of the world's energy will be going into AI. Broadly speaking, what some AI purpose.
Yeah.
Um,
Yeah.
and also water for cooling. And I feel like, and I'm not the expert, you are, so I'm going to ask you. I feel like RISC-V has some advantages to offer on both of those fronts in terms of the flexibility in design and things like that to be energy efficient and potentially to have more easier methods or different methods to manage heat. Can you
Right.
tell us a little bit about that side of this?
Yeah. So when you get into down to this part of the design, it really gets to be vendor specific, because as a vendor is trying to target a particular part of the market, be it more on the embed or edge, or again in something that's a data center, they're going to make specific kinds of choices.
Yeah.
And so in the RISC-V world, so now I'm gonna take this somewhere where it's future looking.
Yeah.
When it comes to AI in general, we have actually three efforts going on right now as far as how do we accelerate things. So right now, current state of the art is you've got RVV, which is all about kind of vector computing, and so as a result, part of the ISA has been extended to do vector computing, and that helps AI to a certain extent, but it can be even better. And so we have IME, VME, and AME that are all kind of percolating in amongst the committees as far as how can we accelerate and even be more efficient in these AI environments. And so the difference between these three is IME is all about doing more matrixy kind of math, but using the current vector register files that have been created. So it's kind
Mm-hmm.
of just extending it, but taking it a little bit further. VME then adds accumulators that would be specific for matrices. So you're still using register files, but you're sort of just mixing in a little bit more for the accumulators and kind of some of the things that you do with matball and all that kind of good stuff. So hand
Yeah.
wavy there. We won't get into the deep math. But then there's AME, and so what that does is that introduces the concept of register files, which are matrices themselves. So it's not using the vector register files, but actually introducing whole new ones. And so the thing is depending on which one of these three that you as a vendor might choose in the future, you are going to use more real estate on your silicon, for something that's more high end, but then maybe you're targeting something that's, cloud computing or, really cutting edge, or maybe you choose like IME. And so that's something a little bit more maybe modest as far as, what it's going to take up, and uh, what ultimately you get for a profile when it comes to power and all that kind of good stuff. So
Yeah.
this is where the brains in the room are again trying to turn the crank in innovation, to come up with something that again is going to hopefully meet these power profiles and make it better.
Yeah. It's a really important but interesting problem. It's
It
it's
is.
one of those ones where for years I've said that the I expect the big next innovation to be batteries. We've been sort of stuck on battery for a long time
Yeah.
with we know how to make pretty good batteries, but we haven't moved to phenomenal batteries, crazy, infinitely rechargeable, whatever the version of a battery would be, or something that doesn't lose energy over time. Who knows? Whatever the innovation is. Um, I'm shocking no one, I'm sure. I might be wrong that the next big innovation might actually be um in this kind of efficiency of energy use rather than storage. Um but I'm still going to claim partial credit for being right about it being energy. So
Well, there you go. Claim that credit. Yeah, and it is a bummer that battery improvements, they're like 5%, 10% here and there, as
yeah,
opposed to 2x or something along those lines. But
right,
I
right,
I
right.
think you're right. We've got to get more efficient. And hey, we've got this brain thing, and it's a pretty
Yeah.
efficient computer, and it's not like it's running at a gigahertz.
It's an interesting that's such a good point. Like it's possible. We can see that it's possible. So I'm looking forward to biomass flavored batteries coming up. Um as we're getting near the end, we're getting to my favorite part of these conversations, and the most fun part, where I get to sort of give you the microphone, metaphorically, and say, what are you excited about? What's the part of this, the the joining RISC-V and the RISC-V space that sort of gets your engineer brain churning, and that you're excited to get your hands dirty with, or see where it goes.
Yeah. So I think the thing that's most exciting about RISC-V International is we kind of had this philosophy where it's you have both great hardware and great software. You have to have both to be super successful.
Yeah.
And for us organizationally, we have RISC-V International, which is sort of all about the hardware and kind of where are we taking that, and enabling a future set of vendors to come up with future cool products. But then we also have this sister organization called RISE, which is all about the great software side of things. And so
Yeah.
we sort of work hand in hand and, whisper in each other's ears and like, hey, could you do this? Hey, you might want to, take advantage of this new cool feature, which is coming.
How dare
And
you
so
suggest that software and hardware work together?
who knew? Who knew? But the point being is that in order to make these kinds of things happen, you have to have collaboration, and that collaboration happens on many different levels. So there's collaboration on the designs and where you can take the ISA in the future, or the specs that set next to those ISA extensions. And maybe it's something in boot, maybe it's something in debug. We've got security. There's a whole bunch of things that are just kind of noodling around. And the great thing is in RISC-V International as well as in RISE, there's a great set of brains that are gathering around the table doing cool stuff on a day-to-day basis, and it's resulting in some pretty great things for us to talk about here today and tomorrow and all that kind of good stuff.
Absolutely. And my last question is always the same. What didn't I think to ask you, because I don't know any better, that I should have, that we should definitely let the engineers listening know about?
Okay, well, I think the thing that I would pass on engineers, at least as far as a question, if you will, is a sort of how do you collaborate with us? How do you get involved? So, and the great thing is there's a number of things that are coming up. So one of which is we've got RISC-V Summit happening in June. So this is going to be over in Europe. So that's kind of the next place to come together, and that still being planned right now, but it looks like it's going to have some very strong hardware tracks as well as very strong software tracks.
Nice.
So we'll be getting out the call for papers and all that kind of good stuff. But then just even in general, I mean RISC-V International, it's pretty easy to join. It's very easy to attend our meetings and things like that. We've got all these mailing lists and things like that. So RISC-V.org, just go there. That's on the website. You can go and jump into our wiki and into our mailing list, all that kind of good stuff. So yeah, pretty easy to get involved.
Absolutely. And I think all the engineers who are all reasonable people would agree that there's enough room in the marketplace for whatever your IP is, whatever you want to do. They all have their own use cases, and even when they overlap, there's enough room for everybody. So get versed in RISC-V if you're not already. Get involved in the RISC-V International organization. And thank you so much, Tom, for joining me today. This has been a lot of fun. It's nice to chat with you.
Thank you, Ken. I really appreciate the opportunity. So
the pleasure's mine. And folks out there listening, thank you so much for listening to Embedded Insiders. Make sure that you subscribe to us on all your favorite podcast platforms. And if you're watching us here on YouTube, hit that subscribe button, like us, share us, do all the things so that everyone out there in the engineering community gets a chance to, at the very least, hear what Tom has to say, if not me. Thanks, everybody.
Now here's Rich Vin and Kevin Liu of Stevens Institute of Technology.
And welcome to yet another episode of Dev Talk with Rich and Vin. I'm Rich, and that guy over there is Vin. How you doing, Vin?
I'm great, Rich. How are you?
I am good, and I'm really excited about this discussion that we're going to have today.
Yeah, I am too.
It's so intriguing, and to fill the audience in, we're going to talk about AI and education, and we can go in a lot of different directions with this, but I think the part that's most intriguing to me is where does somebody who's graduating today, is that job that they thought they were that they would take even be there, or will it be taken up by an AI bot? So is that valid?
I think it's a legitimate concern in terms of discussion, but I don't, I've maintained that people will not be replaced by AI, but they'll be replaced with people who know how to use AI, right? So this now becomes an engineering education implication, because do we teach them how to use the tool that we don't want them to use to cheat on their education so that they can use it as a tool when they get out there and be more valuable? There's lots of stuff, going on. And as you know, I'm still very involved in engineering education with the, schools that I taught at during the pandemic. And, I sit on some advisory boards, and one of them is the advisory board for the electrical and computer engineering department at my alma mater, Stevens. And I know you went to NJIT, and we have this sort of rivalry going, you and I. But I'm going to stack the deck a little bit, because I'm going to bring another Stevens person in who has been a longtime professor there and has become a friend of mine, because we have worked together with students and on projects in senior design and on the board, and has recently been promoted to Associate Dean for Engineering and Science for Undergraduate Studies, which is very exciting. So I'd like to introduce Kevin Liu to everyone. Kevin, welcome to the program.
Oh, thank you for having me. Yeah.
So we're going to throw you right to the wolves right from the beginning. Let's go back to the education part. How do you stop a student from overusing AI to cheat his way through college?
So at Stevens right now is the topic that all the faculty members are very concerned. And so number one is the school needs a policy, and we have one. It's in all the course syllabus. We have a syllabus template, and the template has a guideline about how to use the Gen AI, generative AI, for coursework. And it's a big challenge for faculty member, because faculty member need to redesign the assignment. So to minimize the way a student just use Gen AI to produce work, which is not exactly theirs. So the first step we took was that we asked students, because it takes time to migrate the entire coursework into the Gen AI compatible platform. And so in transition, we ask students to at least cite, say if they use Gen AI, say Gemini, to produce a picture or an image or anything, or the code, and they have to learn how to cite it. And they are standard way right now for citation. And so they learn that, and also we start to redesign our assignment. And the assignment used to be that solve this problem, right? And now become more like what are the steps to solve this problem? So the student have to still retain critical thinking for the problem solving. And these skills are still very valuable. And so about the job, you say about the job, when they graduate, like 3 or 4 years later, or 5 years, some student took co-op.
That's me. I'm the 5-year guy.
So whether the job is still there, right? So the job may continue to evolve like they have been. Students just need to learn how to adapt to it. And so 4 years or 3 to 5 years is a good time to transition, to transform. And
but are you helping these students? Are you preparing them for the AI world?
Yes,
because it's so new. I mean,
oh yeah,
how do you even know what the AI world is at this point?
Well, I think officially it started all this impact on 2022 November, right? It's because of the ChatGPT release, and all of a sudden, everyone start to realize this is going to have revolutionary impact, and here we are.
Do you teach students how to write code now? When that I could just pop it into ChatGPT and it'll write it for me.
Well,
do I need a class to do that?
I got to step in here now, right? Because I've seen the results of this, and if you think about it from the education side as well, there's two things. You've got assignments and labs that you do that are supposed to teach you something, and then you have your evaluations of whether the student has absorbed the knowledge and can apply it or not. And I think honestly, the biggest transition and mutation, if you want, that has to happen is in the evaluation side of things, because this is not going away, right? I remember when calculators came out and everybody's like, they have to do the math in their heads or on a piece of paper and blah, this is going to make, and then we had the same thing happen when simulation came out. People will hook any wire to any wire. And then when it finally starts working, they don't know why it's working. They won't be able to fix it if it stops working. And we've survived all of those things. So if you look at it as a tool and not something, and you have to be careful, engineers can say this, but the financial people will be like, well, can't we just get rid of the engineers and have code written for us? And the answer is, yeah, if you want to lose the company in a few years because the product is no good anymore, right?
But the AI is continually getting better.
Yeah, it is. And someone said to me something the other day, which was really great. He said, AI is as bad as it's ever going to be right now. It's never going to get worse. It's only going to get better, right? But the answer is it still doesn't know everything. And even if it knows everything, it doesn't necessarily know what needs to be applied, right? How does it parse the myriad of information it has in order to know what's valid for this? And that's going to get better over time too, but probably not in the lifetime of someone graduating now or in the next 5 years. What they may use stuff for is assignments or lab work. And you can say, well, they would learn more if they did the lab work or the assignments on their own. But there's always been collaboration. And interestingly, when I was teaching and we were using, LMS systems, and I was actually putting quizzes and things right in there, I got criticized by other teachers by giving them 2 shots at every test. And I said, no, I have checked this out. When I do their end of term evaluation on their project, I've gone through because you can see on the LMSs what questions they got wrong and corrected the second time, right? I made note of that for every student, and I asked them questions about the things that they got wrong, that they then got right, and they still knew them. And so the fact that they were able to learn them by failing at a quiz and then getting it right the next time is still a valid learning journey experience, right? Because the idea is at the end of this learning experience of a semester, of a year, of a whatever, they have some kind of ownership of concepts that we said we wanted to teach them in that class, right? Every class has defined for it some learning objectives, right? These are the things you need to know by the time you finish this class. And however you get there to actually knowing it and understanding it, I think is a valid part of the journey, which is going to morph over time. And so how we incorporate these things in assignments, in labs, I always encouraged my students to collaborate on homework. I'm like, you just can't submit the same file, change a variable name. But if you guys worked on it together, then it's okay, because you know what? You're going to be working together when you get out of school, and being able to work on a team and not be the old engineer that was, locked in a room and you threw meat at him once a week. You need to be able to work with other people. And that starts right there in school.
Right.
So that's it, Kevin.
Indeed. Yeah. Right.
What are you hearing from the students? Are they concerned about what they're going to be doing when they graduate? Is this a concern of theirs?
Yes, we just did a survey, and yeah, right. So, but it's still, if you put into a Likert chart, it's still their population. It's like so it's like three different bucket. So. One is very concerned. The other is, well, not too concerned, but there's somewhere in the middle. They feel it could be a good opportunity, and so we did survey, and we are doing survey not just for students, but also we are doing that for faculty member, because there are always a adoption rate. Some are the early adopter. Some faculty and some faculty member just wait and see. So the survey will end in about a week. So once we gather the data, we are going to have a meeting. So I will be moderating a panel and analyze the data, presenting the data, and then have a discussion. So we are in the middle of this.
Are the professors concerned about their own livelihoods?
Oh yes, because they were actually a lot of speculation said we don't need instructor anymore, right? We just need to have an AI product. Actually, nowadays there are a lot of startup company producing this AI product for classroom, and basically it design it based on the syllabus. They design the coursework, and they have evaluation like Vin you just said. The evaluation and assessment has to evolve as well. So what they did is that they use the the band Bloom's taxonomy. Is like a pyramid, right? The bottom layer is they have a revision. It's the bottom layers remember, understand, explain or apply, and then evaluation and create. The top value is to create something novel, something new. And that is the hard part. So the principle is still the same, but the AI tool become, say, they facilitate the student discussion. They actually, the goal is to let students discuss. And they
Now, I know
for
the audience
themselves.
can't see our faces, but if they had seen Vin's face when I asked the question, do we still need professors? Vin, I think you think we still need professors.
I do. It's funny. We've talked about my love for Italy, and I am studying Italian with a guy in Italy online, and all my
Are you
relatives
sure it's
over
really
there.
a guy?
It's really a guy, Italian
Okay.
teacher Tony. He's really great. He lives in Verona. He grew up in Sicily, and my cousins over there, especially the young ones, were like, how much is that costing you? Why are you paying all that money? You can just use, any of these AI apps. And I said, I want to learn from another person. I want to be able to have some tangential conversation, because I'll say something and it'll lead us in another direction that the AI wouldn't lead us in. And a really good example is I wrote something for him and I used a word that he was surprised I knew. And I said, you need to understand, when I was in high school and we learned languages, because he's a young guy, he's in his late 20s. I said, we memorized conversations between people. And that's how we learned vocabulary, and that's how we learned grammar. And we learned culture at the same time, because we knew how people addressed each other and, what the situation was in that this conversation was in. I said, and I will tell you, I still remember word for word the first two. And he said, tell them to me right now. And I went through both of them, and he was like, it's amazing that 50 years later, you still remember these two conversations. So that never would have happened if it had been Duolingo or something like that. So I think these Socratic conversations that you have with your professor are incredibly valuable in maybe not remembering, but in understanding and applying, because you get the tangential knowledge, not just the piece of information.
So are you talking about making them into better engineers or making them into better people?
Is there a difference?
Absolutely.
No, there is not.
Kevin, is there a difference?
Well, engineer is more specific, right? Because but I agree with Vin. You still need to have so we call this well-rounded model, right? So we want to have engineer is ethical, right? And Vin, I totally agree with you about this human interaction aspect of education. It's very important. It's like we turn on the camera, we can see the body language, right? And
Sure.
Even though we cannot, I can even feel the warmth, right? The enthusiasm, things like that. And with AI, it's kind of repetitive because right now I turn on YouTube, a lot of talking head is AI generated, right? And you can see the repeating pattern, right? It's hand gesture is like every so often has something. It's programmed.
Yeah. It's like the famous M dash, right? If there was an M dash in something, you knew it was probably generated by ChatGPT, and they went and fixed that, right? So
that's very funny. Okay, so let's use the crystal ball. Let's go out about 3 years, say. What's the world going to look like with all this AI interaction?
You take it first, Kevin, and then I'll give my view. Go ahead.
Well, 3 years from now, wow. I think most of the engineering discipline is still there are certain engineering discipline may advance faster. Computer science may be the first one got impact significantly. Electrical and computer engineering may follow. But the engineering aspect, I'm not too concerned, right? Our lab is still, we still want students to learn, to touch the embedded system, visual. They can see it, right? Not just seeing something on the screen or. So that aspect, I don't think will change that quickly. And so I'm hopeful that student will be able to use AI tool and still retain their critical thinking and can still produce innovation. It's so I think we are not quite there yet, but we are kind of evolving with the current trends.
And we'll be having this conversation from the back seat of your autonomous vehicle, right?
Probably. That's okay. That's okay.
But that can happen today. It's just not every or like everywhere yet, right? So right.
Vin, I know you want to answer the question. Go ahead.
Oh yeah, I do. I have 3 overlapping thoughts in a Venn diagram, or what I like to call a Venn diagram. So the first is that it's going to be different for different industries and different technologies. For something like a PC or a server or Linux or something where code is being written to a well-defined API that's ubiquitous, you're going to get more AI work done there because you don't need to know anything about the system underneath because you know what the calls are, you know what they do, they're well-defined, and you can get code for that. You won't get that transition as quickly in an embedded system where every piece of hardware is different. Every API you probably have written yourself, even if there's an RTOS, that's only for task switching and stuff like that. So that is going to be a place where there still is going to be a lot of human interaction in engineering. And certainly, depending on what part you pick, some are more popular than others. And so there'll be more for the AI to draw information from the web, from other places, right? So that's the first thought. The second thought is it's not just about 3 years out, it's more than that. If you think about what I call the pyramid of expertise, you have a large population at the bottom, which are kids coming out of school and doing that. And then some of them decide engineering is not for them. Some of them want to make more money and become, salespeople and maybe even in technology or in marketing or start their own company. And so the population gets smaller and you move to the mid-level engineer. And then from there, more people maybe go into management or other things like that. And then you have your experts at the top of the pyramid. It is the experts that are driving and interpreting the output of the AI that is being used for the menial tasks that are being done by the people in the lower end of the pyramid, which means the population at the bottom is smaller, which means we have fewer people to pick from to get to that next level, and we'll have fewer experts. So suddenly you will have AI generating things, not being evaluated by experts because they're just not the same level. And so now
that's a bad thing.
what the AI is learning in the future is suboptimal. So now you're going to get this dip in AI effectiveness because they're reproducing bad designs until it turns around again. I think it's going to be an effective tool. And my third thought is that it may transition what engineering looks like. There are a lot of companies looking. I mean, when you do simulation, you'll simulate the analog part. You may do some simulation of some code, but nobody is simulating end to end a full system, right? In one package. If we get there, there will be a what I would call real world modeling engineering, where you actually have to create the excitation of the real world for this fully simulated system. That doesn't exist today, or it's a very small thing. I think that's going to be an evolution in engineering. And I think prompt engineering and how to interpret the output, just like debugging and troubleshooting is an engineering discipline, right? Test engineering is its own separate thing. The ability to do that, to write prompts to get effective answers, is also going to become an engineering discipline. So I think those three things overlap to say, this is where the sweet spot is if this is going to be an effective thing. And we'll find that just like, Stephen's electrical engineering student takes mechanical engineering classes, right? Because there are implications in the larger puzzle for the thing you do in your piece. And I think that's going to happen everywhere. You're going to learn to do prompting, even if you're designing circuits. Just like you now have to learn simulation if you're going to design circuits. Nobody's sitting there and doing, differential equations out on a piece of paper with a pencil anymore. Maybe some people, but not the lion's share of engineers. So.
Wow. Well, thank you for that very brief explanation.
I think about this a lot.
Really?
Yeah, I do.
Yeah, I do have concern. My concern is the student is now lacking the, I call it diagramming skill. Programming is okay, they can get it out from chatbot. But diagramming right now, not many tools available. They are tools, and many of them are free for students. You can generate flowchart by text. You give the chatbot the text, and they produce this flowchart for you. So I saw students have a lot of that. Basically, I asked for a flowchart. They came back with a text described flowchart, but not a flowchart itself.
That's actually very funny.
So this is something, it's my concern. I'm still working on it, try to motivate students to still use the diagrams, any kind of diagrams.
Yep. That's awesome. I would love to hook up with you again, Kevin, a year from now and see where this has taken us, because it's a whole new world out there.
Yep. Yeah. Great. Well, Rich, I'm hoping that sometime in 26, we do a roundtable of people in education, people in industry, people supporting the transition, and even some graduates who have been out a few years to see what their world is like. And Kevin can be part of that. We can do a live video thing. Maybe we'll host it at Stevens. We'll do it there. You're from New Jersey.
I do a bunch of podcasts with CEOs, and I very often ask them if an entry-level engineer should be concerned whether he'll have a job or not. And the answers are pretty much across the board. I've had everything from, no, of course not, to, yeah, you better believe it. So there's no real consensus.
I go back to, you won't be replaced by AI, but you could be replaced by somebody who knows how to use AI, right? Okay. It's all about the tools. It's all about knowing how to use the tools and how to interpret it.
Very good. Well, thank you, Kevin. Appreciate you taking the time.
Yes, thanks for taking the time and joining us. I love these conversations, and you and I have them all the time. And now there's one of public record. So
there you go.
Thank you.
Gents, have a great day.
You too. Bye-bye.
Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.